Let's take a look at how ANSYS AIM solves nonlinear contact problems with ease. In this example, we'll simulate a snap-fit insertion with the goal of observing stress during the insertion process. AIM uses simulation process templates to guide you through the steps required to solve the problem. In this case, we have chosen the structural simulation process template. All tasks are automatically defined and best practice defaults are established for each task. Once you're satisfied with your imported geometry, it's time to generate the mesh. Mesh generation is automated and physics sensitive, so the mesh you get is often already optimized for the task at hand. In addition, you have many global and local mesh refinement controls. For example, use automatic curvature-based refinement to capture rounds and fillets in your geometry. Since the quality of the mesh is critical to ensuring accurate results, the advanced mesh algorithms in AIM take you beyond what can be achieved in low-end CAD-embedded simulation tools. In the physics task, all that's needed after specifying material properties is to define the symmetry boundaries, displacement and fixed supports, and contacts. In this case, we are enabling advanced nonlinear frictional contact that's required to tackle this insertion problem. AIM provides the same nonlinear contact algorithms that's available in our full-featured ANSYS mechanical software, which is well beyond what your typical CAD-embedded simulation tool offers. The simplicity of setup in AIM, coupled with the advanced solver algorithms under the hood, mean accurate results with little effort. While this small assembly may look simple, the physics and numerics required to solve this problem are quite complex. AIM packages all of this in an extremely easy-to-use, streamlined user interface that brings advanced simulation to the hands of every engineer.